Before we dive into simulating numbers with R, it's important to understand what simulations are and have a grasp of why they are important. So what are simulations? Simply put, they are imitations. And why do we simulate values? Getting data can be very, very expensive. And also it gives us room to try, make mistake, and reiterate the process. And it's good also for education and training. As I said earlier, data can be very expensive. And also if you have some theories that would like to validate, simulations are a great way to go. But before we can simulate any number, we need an understanding of distributions. And what are distributions? Distributions are how our values are spread. For example, a ridiculous example actually. Take a look at this bread. I know some of us are used to spreading our butter on the surface of the bread that we just want to bite. Others are used to spreading the butter all through the surface of the bread and take the bite. And now, a more serious example, a class setting. This is a marketing class, and in the marketing class we have students with different heights. We have the short ones to the tall students, also of different age in varying spectrum from 30 to 35 to 20 to 17 to 18, and test scores, which is usually capped. And we also have students that fall within a group that love a particular subject, and we have regular students and those that are absentees. Another example is in a research setting. We have varying diameters for this plantation, and the age of the tree can either be uniform, meaning they are the same, or they are different, or true. The number of species also. Now we'll go to the type of distributions, and we have a lot of distributions, but we'll boil it down to 4: normal, uniform, binomial, and Poisson distribution. Now to normal distribution. Normal distributions are usually bell-shaped, and a good example of that is the height in a classroom. We have the very tall one, we have people that are within the average of the class, and we have the very short people. Then the uniform distribution. The uniform distribution is always having a probability of equality for each element. What this means is that, for example, in a deck of cards, the probability of drawing a spade, diamond, or any other suit is equal. And it's also the same for a die. That's another example of a uniform distribution. Then we have binomial distribution. Binomial distribution outcome are always 2. Yes or no. Head or tail. You make the basket if you are playing basketball, or you miss the basket. Then we have Poisson distribution. And this is used also a lot in research. Poisson distribution is count data. For example, the number of time that an animal would appear given a time interval in the camera trap, or the number of buses that would appear within a time interval. These are examples of distribution. In the next class, we are going to see how to simulate each of these distributions in R.